Okay, so at this point, take a moment and try 11 E.2 number 1. Using the information you're given, use the template that we just filled out for that previous example, for example 7. Use that to help guide you onto in terms of what you need to set up in order to run your chi-squared test. So if you want to give this whole thing a shot and then watch the video, I'll have the full answer key up here as you watch the video. Okay, so your contingency table. This is simply the observed table. Just remember, that's just the observed table. And then the expected frequencies table. So just to go through a quick reminder, quick calculation for this cell right here. So for medium and non-diabetic, I would be taking 216, which is the row total, times the column total, and dividing it by the table total. So that would be 216 times 87 divided by 272. And that should be 69.1. And again, that corresponds to this cell from the observed table. The observed table. Okay, so the expected value, the row total times the column total divided by the table total gives you the expected value for each cell in that table. So once we have those, then we can jump into the null and the alternative. Notice I'm not labeling these as step 1 and so on. You don't need to, and it'd actually be better if you don't. Those are just listing out, making sure you know all the things that you have to do to set up a chi-squared test formally. So the first thing is, again, null and alternative, simply stating that these two things are independent and these two things are not independent. Notice the wording of those statements are the exact same. It's just inserting the word not for the alternative hypothesis. For your degrees of freedom, again, degrees of freedom, row total minus, or number of rows minus 1 times the number of columns minus 1. So that's just, again, 1 times 2, and we end up with 2. Significance level, they tell us. So they tell us at a 5% significance level. According to the degrees of freedom, they also give us the critical value. Notice in this example, they tell us the critical value that we are supposed to use. That should match up, if you look at the chart, with the number of degrees of freedom and the significance level we're choosing, 5%. So that means we can write our rejection inequality right away. That means we reject the null hypothesis. So we reject the null hypothesis if our calculation that we make is greater than 5.99. That means there is enough difference between the expected and the observed values that it seems like there is some sort of influence that one of the variables has on the other. Okay? So we reject the null if the calculation is greater than the critical value that we just identified, right? In this case that we were given, right? 5.9. So using your calculator to make those calculations. If you're still having issues with that or you weren't sure, again, doing a quick Google search or using some of the other videos, the links I provide to do so, make sure you can enter data into a matrix and then running the chi-squared test. If you can do that, the value you should have gotten for your calculation is 6.61. So let's stop and think about what that means. 6.61 is greater than my critical value, right? So my calculation, 6.61, is greater than 5.99. That means for this test, we reject the null hypothesis, which means we accept the alternative. And the alternative is that these two things are not independent. That means there is some sort of influence that the one has on the other. Okay, so this test came out that we did reject the null hypothesis in favor for the alternative. That means there was too much of a difference between the observed values and the expected values. Okay. So the p-value, if you looked at your p-value, the p-value should clarify or verify that. Again, the idea here is that the p-value is less than our significance level. So again, our significance level as a decimal is 0.05. The p-value is 0.0368. That is less than the significance level, which again supports. That should always verify our conclusion that we make with the null hypothesis, with our critical value.